All right, here we go. 3.3 properties of nigga, you don't properties of logarithms. All right. So our main understanding here is logarithms and exponents have corresponding properties. So you remember our exponent laws that we learned? Okay, we're gonna learn, the log versions of these properties. Okay. So the definition of a log, which we've learned before, is asking, is the exponent to which must be raised to get m, right? What this base raised to what power equals m. So we've already learned before that when you're converting from log base b, x equals y, your base is going to stay the base, right? The solution becomes your, why isn't it drawing? Technical difficulties, definitely. Let's try, there we go. Your b, it becomes b to the y equals your x. When you have natural log of x, natural log means that you actually have log base e of x. Okay? So it becomes e to the y equals your x. Okay? When you have common log, that means that your base is automatically a 10. So you're asking 10 to what power equals your argument? Lee, can you turn on the music for me, please? Can you turn it? All right. Okay. So these are things that we've already learned. All right. So let's practice reviewing how to convert between logs and exponentials. Okay. So again, the base of the log remains the base of the exponential. Do you remember that? So really quick, what is this in exponential form? Mm-hmm. Perfect. This one. Uh-huh. Perfect. And then the last one. Natural log means what? Your base is what? There we go. E to the what? Uh-huh. Equals C. Do you remember doing that? Okay. Yeah. All right. Now let's undo the exponential and write it as a log. So undoing the exponential and writing as a log, remember the base of the exponential is still going to be the base of the log, right? The base of the exponential is the base of the log. So what is 4? Uh-huh. Log base 2 of 1a equals -3. All right, what about 5? Do I have to write the 10? Well, you can, but log of 10, what's my argument? Equals 0. And you can just write this as log of 1 equals 10. And that's because it's a common log. Anytime the base is 10, it is common. All right, 6. He said log, we can do log E. And we can write, uh-huh. And what's the other way I can write this? Mm-hmm. There you go. Yes. Yes. I tried to put a little tail on it. You see it? What? It's a little tail on it. All right. So we already have this baseline of knowledge, right? Okay. Now we're going to move into simplifying log expressions. When we're simplifying log expressions, we have properties, just like we have laws of exponents, we have properties of logs. So up first are property 1 and property 2. Property 1 and property 2 are what we call our inverse log, our inverse properties. So these are our inverse properties or identity properties, basically, essentially. No, they're inverse properties. You think someone's what? Yeah. Is it bothering you?
No, but I was like,
We can't do nothing about it. Yeah, it's soothing. All right, our inverse properties. So basically, if the base of the exponential and the base of the log are the same, that means that the solution is just the argument. Does that make sense? Okay, so if the base of the log and the base of the log and the base of exponential are the same, the solution is just the argument of the log. Okay, now if the base of the log and the base of the argument are the same, then the solution is just the power of the base.
what's the difference?
Okay, one is your base. One is an exponential with a log as the power. The other is a log with the exponential as the argument. Okay, so let's look at this one. So this is going to be using property number one. Using property number one, the base of my exponential and the base of my log are the same. So what does this equal? 18. Yeah. Okay, using property number two, the base of the log and the base of the argument are the same. So what does that equal? X minus 2. Yeah. Mm-hmm. Exactly, because they're inverse operations of each other. So they're canceling each other out. Okay. These rules still apply when it's not just regular log, but natural log and E. So this is an example using property number two with natural log. Natural log and E are inverses of each other. When they are next to each other, they're going to do what? So what am I left with? 3t. Again, natural log and E are inverses of each other. So when they're next to each other, they do what? They cancel each other out, and we're left with t squared. Okay, how do we feel about inverse properties? Not bad at all, right? Okay, so if I need to cancel out a log, I'm going to use an exponential, right? If I need to cancel out exponential, I'm going to use the log. Got it? They're inverse operations. Okay, next we have properties 3, 4, and 5. They are very similar to your laws of exponents, right? So property 3 is if I have an argument that is being multiplied, I can expand the argument by turning it into addition. So this is our product property for log. Make sense? Okay. Isn't it very similar to our product law for exponents?
Yeah.
Yes. Okay. So here we have log base 4, 5 times x. My factors are 5 and x. So based on property number 3, it can expand to become addition. Log base 4 plus log base 4, 5 plus log base 4 of x. Simple, easy. Okay. Now we can go the opposite. So if I need to condense based on this property, I can take two logs that have the same base that are being added together and I can multiply their arguments. Does that make sense? So my log base is 2. My two factors are 6 and 10. So this becomes, if it's addition, then you're going to end up becoming multiplication. So log base 2 of 60. Yes. Okay. Questions about property 3? Nope. Okay, let's keep pushing. Okay. Property 4 is our quotient property. Okay. Property 4 is our quotient. Okay. So with quotient, If I am dividing within my argument, I can expand it to being two subtraction problems. Make sense? Okay. If I am subtracting two logs with the same base, I can condense it to be a division problem. We see that? Okay, so let's practice. So this time our log is natural log, and we have the natural log of 6 divided by x. Okay, it's going to always be your numerator minus your denominator. So we end up with the natural log of 6 minus the natural log of x. It was supposed to say ln on y'all also. Did I write log on y'all?
Yeah.
It doesn't. Does it really matter? No, it doesn't. It's natural log. It just means it's a log with a base e. E is an irrational number, like pi. All right, here we go. Now, what if I want to condense? So your first term is your numerator, and your second term is going to be your denominator. Okay, so we have natural log of 50 divided by 25, which equals what? ln of 2.
Yeah.
Yay. Property 4. How we feel? Okay. No, you're fine.
Oh.
Got it? Okay. All right. Next is property 5. Property 5 is our power property. Our power property. So our power property tells us that the power of our argument can become the coefficient of our log.
That's it.
And vice versa. The coefficient can become the power of our argument. Okay? So when I'm expanding this, that means I'm taking the power of my argument and turning it into the coefficient. So the answer becomes 3 log x. Okay? If I'm condensing, that means the coefficient is becoming the power of the argument. So we get log base 2 of 3 squared, which becomes what? Log base 2 of 9. How do we feel about the power property of log? It's okay? We're good?
Yes.
Okay, what's the question? So this can become,
I'm just trying to write it all down.
okay, on this property? So this property is just saying that the power on your argument can be written as a coefficient. And then vice versa. If I have a coefficient, it can be written as a power. So whether you're expanding or condensing is how you're going to use property 5. Okay?
Oh, we get to do the next one by ourselves.
No, we're going to start together.
There you go.
All right. So our job here is to try to get this down to one single algorithm using all of our properties. Okay? Before you start, when you're condensing, you're going to always start with property number 5. Okay? So property number 5 is our power property. So we want to always start with property number 5. So power property is saying that I'm taking my coefficients and they're becoming powers, right? So 3 is going to become the power of Q and 6 is going to become the power of V. Yes.
Wait, is that a 0 on the bottom?
It's a B for base.
That's cute.
That's a Q. Okay. So we have log base B Q to the 3rd plus log base B V to the 6th. All right. So that's property number 5. Next, you're going to decide, are you adding or subtracting so that you can know if you're using property number 3 or property number 4. So in this case, we're doing what? We're adding. So is that 3 or 4? 3. So we're going to be using property number 3, which tells me if I'm adding, that I can take my arguments and multiply them, right? So this becomes log base B, parentheses, Q to the 3rd times V to the 6th. The last thing you do is check to see if you can simplify. So that means combining like terms, multiplying, checking to see if you can apply property 1 or property 2. If none of that can happen, then you are done. So can I simplify? Nope. So guess what that means? That's our answer. How was it? All right, let's try it again. So on number 2, again, you start with property number 5. So I'm going to apply property number 5, which means I'm taking the powers. I'm taking my coefficients and turning them into powers. So we have log of x to the 4th minus log of x plus 2 to the 6th. Step 2 is to decide, are we adding or are we subtracting? We're subtracting. Okay, so we're subtracting, which means that we're using property number 4, the quotient property. So the base is going to stay the same. The argument of the first term is the numerator, and the argument of the second term is the denominator. I wrote the 6 in the wrong spot. You saw nothing. All right, and then the final step is to simplify. Can I do anything to simplify this? Nothing can be canceled out. Nothing can be evaluated. Nope. They're not like power. Nope, you can't distribute the 6. That means you have x plus 6 times 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 x plus 6. And we're not about to do that, are we? No, it gets us nowhere. X plus 2. I'm going to say x plus 2, not x plus 6. Ignore that. All right? But the moral is we can't do anything. All right? Next, we've talked about this before, is our change of base. Change of base is useful when you are evaluating and simplifying, but it's also just a useful tool that if you don't have a large scientific graphing calculator with you, you can always calculate the log from just using your basic phone. Your basic phone, your phone. All right, so change of base is saying that you can find the log of anything by taking the log of the argument and dividing it by the log of the base. So this can be rewritten as log of 91 divided by log of 3. What am I going to cancel out? Okay, yeah. So I'm going to pull up not a graphing calculator. I'm just going to pull up a basic calculator. This guy right here. Basic. And on here, I'm going to type in 91, the log of 91. And I'm going to do divided by. I'm going to type in 3 log, and I'm going to hit enter. And it says it's approximately 4.106. 4.106 is our approximate value. So you see how you can do that from any calculator? I didn't require a fancy calculator. Okay, so using change of base, what would I type into a standard calculator for this? There you go. Log of the argument divided by log of the base. Then we'd plug this into a standard calculator. Let me open up basic for you real quick. Here's basic. On this calculator, you have to type the number, then press log. I have a Samsung. On Samsung, I got to press log and then type the number. So I don't know what Apples do, but I can tell you what I do. So we type 81 log divided by 2 log, hit enter, and we get it's approximately 6.34. That's all we're writing.
This goes to the right,
Yeah.
it gets like a bit more. Doesn't even matter.
Okay, how do we feel? Okay. All right, here's your exit ticket. Yes, and then you're going to submit your answers. Well, check your answers on Canvas. So you'll do it here, and then you'll be able to check your answers on Canvas and see if you did it correctly. Okay? All right, so this is what we're working on for the remainder of the period. Was today terrible?
No.
It was not. On Apple, y'all don't have law?
We have log, basic